Okay, so 8.3, the inverse of a square matrix. We are going to verify inverses and find inverses using Gauss-Jordan elimination. Those are the two things we're going to do today. Tomorrow we'll solve systems of equations with matrices not using Gauss-Jordan elimination. We'll be using the inverses. So it's another way, like if you think about it, you guys have been taught like 7 or 8 different ways to solve systems of equations. So it's probably one of those things we do a lot in, like, if you're doing math in the real world. So this section further develops the algebra of matrices. So if I were to solve AX equals B, so I would multiply, well, I would divide, yes, for AX, like in regular algebra, I would divide, yes, but there is no division in matrices. So we would multiply by the inverse. Well, isn't dividing multiplying by the reciprocal? Okay, so same kind of thing. So if I multiply, and I'm going to point out that this is on the left, it's called a left-hand product, okay? We know that matrices are not commutative in general, so we stick, if we do left hand, we stick to the left hand. If we do it on the right, we put it on the right. Okay, so we multiply by the inverse, getting 1, because when you multiply by an inverse, you get a multiplicative inverse, which is 1. And then you multiply on the left. So the answer to X is A inverse B. So that is what we are going to be doing. We are going to be finding A inverse and multiplying B, what it's supposed to equal, by it. A inverse is called the multiplicative inverse. Like your entire world, since you've done algebra, that has been a thing, whether you've acknowledged that it was a thing or your teacher insisted that you learned that that was what it was called, that is what it is called. Make sense? Okay. This slide really wasn't important to write down. That's okay. Let me know when you're ready.
Don't write it down.
I'm good.
Okay. It wasn't like vital. Like, we're not there yet. This is just like background. History of math. Okay. Multiplicative inverse, the definition is let A, so this is a book definition, so we want to get a better definition, right? So let A be an n by n square matrix. And you pointed, which word did I emphasize there? Square. Okay. And I sub n be the identity. When you see an I matrix, it is the identity. Okay. The identity matrix of a 2 by 2 is 1, 0, 0, 1. Seen that before? Every time we did Gauss-Jordan, we found an identity matrix. Okay. What do you think a 3 by 3 is? Could you have told me that? What about a 10 by 10? What's going to be? And then what's everywhere else? Zeros. Okay, but that is definitely not a 10 by 10. I only got to 5. But you get the point? Okay, so if A inverse exists, then A inverse equals the identity. And A inverse A equals the identity. So what did I do here? I have A inverse on the right and A inverse on the left. And I keep telling you that matrix multiplication in general is not commutative. What did I just say this was? Commutative. So the only time that matrix multiplication is commutative is if you are multiplying it by its inverse. Does that make sense? Remember when we were finding inverses and we did F inverse X and F inverse of F? We had to do both of them. This is it. It's the same thing. You have to prove to me that AB and BA both equal the identity. And then they are inverses of each other. Does that make sense? Okay. Oh, go back here real quick. A little slow on the uptake, evidently, today. Like some of you. What do I have here? I said only square matrices have inverses, but do all square matrices have inverses? No. Not every matrix has an inverse, and we will discuss how to figure that out tomorrow. Because that is the test that you would do first before you would even go to, by hand at least, find an inverse. You did see, on your calculator you can find them as well. So I hope we will show you how to do that. Okay, so inverse matrix. So we need to see if these are inverses. So I need to do AB and, so I need to do AB and I need to do BA. So let's see, we have -2 plus 3, right? And -2 plus 2. And 3 minus 3. And 3 minus 2. Hopefully I did that right. Did I do it too fast? You guys are not talking to me. So 1, 0, 0, 1. So that works, right? So BA, and I gotta write B over here. I cannot do it. Did you have to rewrite it when you guys were doing it? I just cannot. My brain can't do it. There's enough that it's trying to do. It doesn't need to try to do that too. Okay, so then -2 plus 3 and 1 minus 1 and -6 plus 6 and 3 minus 2. So even though it, like, when I get to a 3 by 3 or a 4 by 4, I still have to do this, but should it, like, break down really easily if they're inverses of each other?
Yes.
Yeah. So, are they inverses? Yes. Yes.
Oh, the smiley face is full of this.
Because it worked. Yay. On the next slide, I'm going to make you do it. Tell me when you're ready, Olive. You good? All right. That is the same numbers, isn't it? There we go. I have the same slide in there twice. So show, verify, and prove all means the same thing, right?
Yeah.
Okay. Okay, did it work?
Yeah. I have a question.
Mm-hmm.
So you're getting like negative 1 plus 2. Where's the 2 coming from?
Oh, on here. So here, it's this times this.
I know, but you have 2 2s.
Oh, on this one?
Yeah. No. I don't know where the first 2 is coming from.
This 2.
I know, but you go.
Because it's you go this times this, and then you go that times that.
Okay.
Row times the column.
Right.
So,
I was not registering for a second. I was high-key confused.
okay. Are you unconfused now?
Mm-hmm.
Okay. Because I'm confused how to answer that because I'm like, it's
Well,
right there.
yeah, sorry. I was like,
That's okay.
I'm like half here.
Okay, that's fine. As long as you're unconfused now, because I really didn't answer anything, I don't think. But okay, so this is just some vocabulary. A matrix that has an inverse is called invertible or non-singular. Therefore, a matrix that does not have an inverse is called singular. Now, you will hear further on things about, it will talk about a non-singular or singular matrix. I mean, those are words you need to know. The only one that really bothers me is invertible, because I think invertible means that I can't do something. Does that make sense? But it's telling me invertible has an inverse. So singular and non-singular makes sense to me, because non-singular means I can do more with it. Singular means that's it, nothing more. But non-singular and invertible mean that it has an inverse, and singular means it does not have an inverse. Now, watch, I don't know if some of your directions use those words. Okay. And a non-square matrix cannot have an inverse. I've already said that. I've said only square matrices have inverses. So now I am telling you a non-square matrix absolutely cannot have an inverse. Because we know that the product of AB times BA would not be the same even if it worked, right? So, cannot. No. Okay, good. Okay, so how we are going to find the inverse today is using doubly augmented matrices. We augmented the matrix before with the variables, like the coefficients, and the solutions, yes? Now we are going to augment a matrix with its identity. And then we're going to do Gauss-Jordan elimination. So we're going to start here. We're going to do Gauss-Jordan elimination. And when we do that, we're going to have the identity on the left. Then what are we going to get on the right? The inverse. Okay? So today, that is what you're going to do. You have 2x2s. You have a couple 3x3s. I think only 2 3x3s, but all the rest are 2x2s. So this process or algorithm works only on square matrices that have inverses. So if it didn't work, if I wasn't able to get the identity, like if I had a row of all zeros, then it's singular. It doesn't have an inverse. Does that make sense? If you would get something that would, if you get a row of all zeros on the bottom, it doesn't have an inverse. It's singular. Okay? So let's do it. Okay, so I have it set up this time. In your book, it's not set up like this, but obviously if it's a 2x2, that is what your identity looks like, right? Do you know what a 3x3 identity looks like?
Oh, wait, yeah.
Yes, diagonal. Okay, now, does it change the fact that the right-hand side has 2 things rather than 1 on it? No. You're still only concerned about getting this to 1s and 0s, and then this over here will become your inverse. Just carry things all the way through it, okay? So, what do you guys want to do first? We'll write it down, I would assume.
Row 1 plus row 2.
Row 1 plus row 2. Okay, did you get 0, 1, 1, 1? If you didn't, did I do it wrong? No, I don't think so. 1 and 0 is 1, 1. Okay. Now what?
4 2 plus row 1.
Negative 4? So that gives me 1, 0, and then negative 4 would be negative 3, and negative 4 would be negative 4. So, do I have the identity on the left now? Yes? So what does that mean this is on the right? A inverse. And that's just with the negative 1 to the negative 1. Now, if I told you to verify that, what would you have to do? A inverse and what? A inverse A? Do that multiplication.
Did you do that on the test?
On the test, I will say verify that these two are. Does that make sense? Like the first example we did. I won't make you, well, unless I decide just to do one problem and say find it and verify it. But I usually do 2 different problems. I usually do one that says find it, and I do one that says verify it. That way I know you guys did it right. Does that make sense? Okay. Not hard. Okay, find the inverse. So I first need to make a doubly augmented matrix. So you have your coefficients. I'm doing this because I will not have room. And what is the identity of a 3 by 3 matrix?
1 0 0 0 1 0 0 0 1.
Yep. And then we just go to town, right? When you guys are ready, tell me what you want to do. Or unless you want to do it your own. Do you want to just do it on your own? No? So Olive, what do you want to do?
I don't know.
Well, you got to get rid of 3 and 2, yes?
Yeah.
So we're going to use 1 to get rid of 3.
3 R1 plus R2.
So negative 3 R1 plus R2. And then negative 2 R1 plus R3.
We can't do anything with
Well, a row of all zeros has to go on the what?
it. Bottom.
Bottom. And I probably am going to do 1/5 just to make sure I'm covering my bases of R3. Switch and do a 1/5. Just because I'm not supposed to and I'm going to. Okay, what does this tell me about this matrix? It doesn't have an inverse because I have what?
Zeros.
Those zeros. And so what's the word I call it?
Singular.
Singular. Now, are you going to get many singular matrices in your progression today? No. But can it happen? Yes. I got one more example. Do you guys need it?
Mm-hmm.
No? Okay. That's it.